Oh my goodness, let's talk about the types of chemical reactions. In class, this is the thing we did the little dance demonstration. So this won't take very long. Let's look at this really fast and let's refresh your memories. Okay, so the first thing we're going to look at is called synthesis. And synthesis is when you have a cation, an anion, and they join together. Ugh, so romantic. When we have this reaction here, what we see is we have Na plus Cl2. All right, now when you put these together, you still have to follow all the formula rules that we did before. I'm just going to use this nice color gray to draw this. So the Na and the C are going to come together. Now Na has to go first because Na is the positive, the cation. Na is +1. Cl is -1. Now don't bring over any of those subscripts. Those subscripts are to fix the charges. So look at this, +1, -1. We don't need to fix those charges, so that's fine. So Na plus Cl2 forms NaCl. And that is the products of the reaction. So everything looks really good so far. But we have to balance it. So after you have all the formulas fixed and everything just right, then you have to balance. So we have to find something different. And looky here. There's 2 Cl's on that side. Remember, Cl was diatomic. And there's only 1 Cl over here. So we need to put a 2 in front of this. Well, we go right to the partner. There's 2 NAs on this side and only 1 Na over here. So we have to fix that. And there's our balanced equation. If you want to put a 1 in here, I think that would be perfectly acceptable. All right, so that's the synthesis reaction. All right, the next one coming up. Single replacement. Oh, this is when I called it the cut-in in class. Remember that? Yeah. So we have Billy and Johnny dancing, and then whoa, look at Marcia coming in, and she just steals Billy right away. And that's it. All right, so that's the single replacement. We're replacing, in this case, in the picture up here, an anion with an anion, but in the example I have down below, I'm going to replace a cation with a cation. And this is one of our favorite reactions, right? We have HCl, which is hydrochloric acid, and we have zinc. H is +1, Cl is -1, zinc is +2. All right, when this reacts, what's going to happen is the zinc and the Cl are going to hook up, right? So ZnCl. All right, let's just fix the formula we're right here, because we know zinc's +2, we know Cl's -1, and so crisscross, we're going to put a 2 right here. You could put a 1 there, but nobody does that. The kids will make fun of you. I'll do it just for you guys. Okay, and then plus H gets sent over here to the punch bowl. Okay, now H is one of those diatomics, right? There's a list of 7 of those. You have to know which ones they are in these. And so H is diatomic. It cannot be alone, so it's going to be called H2 over here. All right, now we have to balance. Let's find something different. I see 2 Cl's on this side. I only see 1 over here, so I'm going to fix that first. Now, I'm going to fix the partner. Now I have 2 H's, and I already have 2 H's. Hey, that's great. That works out. 1 zinc and 1 zinc. Everything's good. All right. Moving right along. Ooh, the old switcheroo. This is double replacement, and we have a positive and negative, a cation and anion, and then we have another couple, and then they swap partners. Okay, now looking down here, we have a reaction ready to go. So Pb is +2, NO3 is -1, right? So we had to have a 2 there. K is +1, I is -1. So we have a positive and negative, positive, negative. They have to switch partners, but the positive has to go with the negative. It's the rules, all right? So we put PB, and that's +2, and it goes with the I, which is -1. And we're going to fix that right now, right? Crisscross. We'll put a 1 in there for fun. All right, plus K. Whoops, what happened there? Get back here. K, and then goes with the NO3. And that NO3 is in parentheses, remember, because that's a polyatomic ion, and we like to keep that all grouped together. When there's just one, it doesn't really have to be in parentheses, but you know what? I like it in parentheses. It helps me keep track of it. It makes it easier to balance. Okay, let's see what we have now. Everything's set up. The formulas are all fixed, right? We have a 1 and a 1. No one's really going to write 1s there, but I did anyway. Okay, so we have 2 NO3s on this side, and we only have 1 on this side, so let's put a 2 in front of that and fix that. That gives me 2 Ks, so I'm going to go over here and fix the Ks. That gives me 2 I's, and I already have 2 I's, so that means I am probably done. All right, and the last type of reaction is decomposition. It's the old breakup. Yep. I'm going to do water here. There's a lot of decomposition ones on this paper because those are the ones that have these certain patterns they follow. And this is the end of the course review, and we're not going to go through all the nitpicky details, right? We just want to make sure that we have the major points. Okay, so this H was +1. I didn't mark that. And this was -2. That's why that 2's there, H2O, right? And so now these are going to break up. So H plus O minus 2. I don't know why I'm putting those charges on there because they're separate. They're not with anything, so they don't really need to be on there right now. But I do know that H was diatomic and it needs a 2 down there because it's diatomic. And I know that oxygen is also diatomic and it needs a 2 down there too. Right? Remember, diatomics only have to come in pairs when they're by themselves. When they're not by themselves, like over here, like the O on H2O, it doesn't have to be in a pair because it's already attached to other things. It already has something else filling up its shells. That's all about filling your shells, right? Okay, now that's done. Let's find something different. 1 O, 2 O's. Fix that first. So we're going to put a 2 on this side. Now fix the partner. That's 4 H's. 2 times 2 is 4. 2 times 2 is 4. Hey, that was an easy balance. We can put a 1 here if you want. And that would be it. All right? Those are the main types of reactions. Now, I also like to include combustion on here. And since I didn't draw it, I'm just going to do it right now. So this is going to be combustion. Sorry about that. And combustion is fire, right? And so this is when oxygen reacts with something. Now, I'm just going to do a hydrocarbon with that. We know what a hydrocarbon is, right? Now we can do that. How about we burn propane? So propane is C3H8. Okay, so you start off with a hydrocarbon and you react it with oxygen, right? You can't have fire without oxygen. And then when they react, they have the same 2 products every time, and that would be CO2, carbon dioxide, plus H2O. Now, remember I have a weird pattern for this, and the reason I have this weird pattern for combustion reactions is because we have this little 2 right here. And that little 2 sometimes can throw a monkey wrench into your whole business, right? It can make an odd number on one side and mess you up, and it's just a pain in the butt. So we're going to fix that problem with my little pattern. Now, you don't have to follow this pattern if you can do it the other way, but this is just the way that works every single time. And I'm trying to figure out, I don't know if this even needs one, but we'll do it anyway. The first thing I like to do, and this is my pattern, first thing, is I like to put a 2 in front of the hydrocarbons. All right, I'm just going to put blah, 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 blah. There we go. No real numbers there. Okay, and if I do that, what that does is that evens up my oxygens overall, and it makes it work out no matter what. And then if I have even numbers, I can reduce at the end of this thing, and everything will be fine. Okay, our next step is we're going to balance the C's first. We're going to balance the H's second. And what we're doing, we're staying away from that O2. We just want to stay away with it, stay from it. Let me rewrite this. The C's, balance the C's first. There we go. Balance the H's second. And then save those O's to the end. And then if you have to, reduce it. All right. It adds an extra step in there, I know that, but it saves you if it has to come all the way around. All right. So that's what I do. Here we go. So for fun, I'm going to put a 2 up here. Okay, now that 2 times 3 is 6, so that gives me 6 C's. 2 times 8 is 16. 8 times 2 is 16. Adding up my O's, I have 6 times 2 equals 12. Plus then I have 8 times 1, which is 8, right? And that equals 20 oxygens. So 2 times 10 equals 20. All right, now look at my numbers. Since they're all even, 2, 10, 3, and 8, I can reduce that down to 1, 5, 3, and 4. Okay, that method will work every single time. You may not have to reduce at the end. And that's the whole reason we use it. If you don't have to reduce, that's a great thing. Okay, all right, well, that's it for balancing equations and types reactions, and good luck.